Problem 2. The number s is equal to 1 times 2 times 3 all the way times n plus 4k plus 3. So in here, we have a number s, and n and k are the variables. We know that n has to be greater than or equal to 3, and that k is an integer from 1 through 100. So how many different values of k allows s to be a positive integer perfect square? Well, we first need to know two very important facts about what it means to be a perfect square. It means that whenever you divide by 3, you have to have a remainder of either 0 or 1. And if you divide by 4, you have to have a remainder of 0 or 1. So that's the case here. And there's two scenarios to this. So the first part is if n is equal to 3. So then s would just be equal to 1 times 2 times 3 plus 4k plus 3, right? If n equals 3. And our second case would be s is equal to 1 times 2 times 4, and it keeps just times 3 times 4, and it keeps going on, and plus 4k plus 3. And why do I have these two separate scenarios? Well, first, we need to figure out which one of these we need to use. Well, I think that the second one divided by 4 would work the best for this one, because over here we have 4k. So if we just look at 4k plus 3, we have to know that 4k plus 3, after being divided by 4, will have a remainder of 3, meaning that this alone cannot be a perfect square. And that applies to this as well. 4k plus 3, right? If 4k plus 3, it has a remainder of 3 if it's just by itself when divided by 4. So that cannot make it a perfect square. But then it won't ever be a perfect square, because then this will start including a 4. And if it includes a 4, then this first part, after divided by 4 will also have a remainder of 0. So if this has a remainder of 0 and this has a remainder of 3, add those together, you still have a remainder of 3 in the end. So this cannot be a perfect square. The second scenario will not work. Our only hope is this first scenario, where let's first simplify this. 1 times 2 times 3 is 6, plus 4k plus 3, which gives us 4k plus 9. Okay, so then in this case, s is equal to 4k plus 9. So this is equal to a positive integer perfect square, and k has a range from 1 through 100. Well, because 4k has to be even, and then you add an odd number to it, then this final sum must be an odd number, meaning that their only hopes would be 5 squared, because 4 squared is even, and 3 squared is too small, because 3 squared is 9, and 4k cannot equal 0. So we'll have 5 squared, 7 squared, 9 squared, 11 squared, 13 squared, 17 squared, we also have 15 squared, 19 squared. Now, can we go on further? Because our next one would be 21 squared. But k has a greatest possible value of 100, right? Because k is an integer from 1 through 100. So if k is equal to 100, 4 times 100 is 400. 400 plus 9 is 409. So 4k plus 9 can only ever be 409. If you do 21 times 21, that's already past 409. So how many different possibilities are there? There's 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 different possibilities.